Hello students, today I am going to deliver lecture on the topic of Ultimatum game. So in this Ultimatum game we have two players. So this is a game of two players. So I am considering that the one player is P1 and another one is player P2. Okay. So to understand this Ultimatum game, we consider a scenario in which the player P1 and P2 have done a robbery of a bank. Okay, and after the robbery, the player 1 is the leader here in this game, and he will decide the share of both the players. So player 1 will decide the share for both the players. Now it is up to the player P2 whether to accept that share or not. Okay, maybe the share if player 1 is greedy, then definitely he will take the more share and the player 2 will get less share. Okay, but if the player 1 is not greedy, then it will give the equal half to both the players. So the player 1 is the in this extension game, the player 1 is the player who act first, means he will take the action first. Okay, and what is the action here? The player 1 action is, the action of the player 1 is offer is a share. Okay, and now after taking an action, the player 2 will act, and player 2 action is what? The player 2 either accept the offer or reject the offer. So the action of player 2 can be accept the offer or reject the offer. So here is a condition that if P2 accept the offer, then the P2 will get that share and the remaining will be of P1, right? So I take an example. Suppose I have 100 coins. Okay, now P1 player can share these 100 coins in several ways, right? So this can be a way. So he is offering here 20 coins, 20 gold coins to the player 2. Okay, and what can be the other way? Here he is offering 50 coins to the player 2. Okay, so this is the greedy approach. So that is why the player 1 has offered less number of coins and the remaining will be of P1. Okay, and here the player 1 is offering 50 coins to the P2 and remaining will be of P1. Now who will act the next? After that history, the player 2 will act, and player 2 is having two options, either to accept the offer or reject the offer. Okay, now as per this ultimatum game, if player 2 accept the offer, then that offer will be taken by the P2. Okay, this will be the payoff for the player 2 and the remaining amount will be of player 1. So here the first value will be of the payoff of player 1. So here the P2 is accepting the offer. So in this case the player 1 will get remaining, that is 80, and 20 will be of P2. Now what if the player 2 reject the offer? If player 2 rejects the offer, then both will not get anything. Why? Because the P2 is not accepting the offer and he will not allow the P1 to take the money, right? So both will get nothing. If P2 reject the offer, then both will get nothing, means the both will get zero payoff. Okay, so this is the ultimatum game. So this is the ultimatum game of finite divisions. Finite divisions means player 1 is offering the finite number of offers. The player P1 can offer finite number of offers. Okay, so here in this game you can see in this game tree, the player 1 is the player who is taking the action first, right? So in this ultimatum game, the player 1 who is offering an offer to the player 2, okay, and he will take the action first. So There are several ways to offer. So this is the one way. Here the player 1 is offering the amount of 0, and this is the second way in which the player 1 is offering the amount of 25. This is the third way in which the player 1 is offering the offer of 50. In this, the player P1 is offering 75, and in this the player P1 is offering 100, means the whole amount he is offering to the player 2. Now after taking an action by the player 1, the P2 will act, and P2 can accept or reject. So in this case, after taking the action of 0, the P2 will act, and P2 is having two actions available, accept and reject. So if he accept, so as per the ultimatum game rules, if P2 accept the offer, then the offer amount will be taken by the P2, and the remaining will be of P1. So remaining is what? Because the amount is 0, so the 0 will be taken by the P2, and the remaining means the 100 will be taken by the P1, right? Now in this case, when the P1 is offering 25, and after this offer the P2 will act, and P2 can accept or reject the offer. So if he accept, so then the offer amount will be the payoff of P2, and the remaining amount will be the payoff of P1, that is 75 here. Okay, if he reject, then both will get nothing, means both will get 0. Okay, so in this case the player 1 is offering 50, so both the players will get the offer of 50 and 50. Okay, now in this case, if the player P2 rejects, then both will get 0 0. Okay, now here if P1 offers 75, then the offer will be the payoff of P2, and the remaining amount will be the payoff of P1, that is 25. If he rejects, both will get 0. Now if he offer 100, then the offer amount, if the P2 accept, then the offer amount will be of P2, and the remaining amount, that is 0, will be the payoff of P1. If he reject, both will get 0. Okay, now what is the Nash equilibrium of this game? We know this is an extensive game. Why this is an extensive game? Because the player are taking their actions in a sequential manner. Here P1 is taking an action first, and after that the P2 is taking an action. Okay, so that is why this is a sequential game. So now how can we solve this sequential game? So to solve this sequential game, we know there is a method called backward induction we can use. Okay, so we will apply the backward induction method in this game, so that we can find out the equilibrium. Okay, so as per the backward induction method, we need to start from the non-terminal nodes of the last level, or can say the sub game of length 1. So first of all, we need to find out the sub game of length 1. So this is a sub game of length 1, this is a sub game of length 1, this one is a sub game of length 1, this one is a sub game of length 1, and this one is a sub game of length 1. So we have five sub games of length 1 here. So we can give a name to each and every sub game here. So this one is S01. S01 means the sub game 0 of length 1, and this one is S11, means the sub game 1 of length 1. S21 sub game 2 of length 1. S31 the sub game 3 of length 1, and this one is sub game 4 of length 1. Okay, now we need to solve first all the sub games of length 1, then we will solve the sub game of length 2, and we will repeat this process until we reach a root node of this game tree. Okay, So far we have not reached the root node. So first of all we need to solve the subgame of length 1. So in this case s01, so we have two actions, accept or reject. Okay, so we have two actions available here. Now tell me which action is best for the p2 here. If p2 accept, he will get 0. If p2 reject, he will get 0, right? So as per this, both are optimal, both actions are optimal. So here the output of s01 is a and r. A means accept, r means reject. Both are optimal here. Now in this case s11, the player 2 if accept, he will get 25, but if he reject, he will get 0. So which one is optimal? So accept is the optimal. So the output of this game is accepting the offer. Now we will solve the s21. So here again we have two actions available, accept or reject. So if he accept the offer, then the player 2 will get 50. If p2 reject the offer, then he will get 0. Okay, so which one is best? The 50 is best, means accept. So again the output of this is accept. Now we will try to solve the s31. Again in this subgame we have two actions, a and r. If player p2 accepts, then he will get 75. If he reject, he will get 0. So which one is best? 75 is best, right? Means accept. Now we talk about this subgame, the s41. Again in this subgame we have accept is the output, right? So now so far we have solved the subgame of length 1. Okay, so step 1, as per this step 1, solve subgames of length 1. So we have 4 subgames, the s01, s11, s21, s31 and s41. Okay, and what is the output of all these subgames? So s01 output is accept and reject, both are optimal. Here in this case accepting is the optimal, in this case accepting is the optimal, again in this case accepting is the optimal, and in this case also the accepting is the optimal, right? Now what can be the strategy of player 2 here? So if we make the combination out of all this output, we can make two possible strategies for the player 2. So if in this game at a time we need to consider one action, right? In this subgame, the output of this subgame, we need to consider only the one as an output. So if I consider accept as an output, so what can be the strategy of player 2? So strategy of player 2 can be accept, 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 accept. So this is the strategy of player 2 when the output of s01 is a. But what if the output of s01 is r? If this output of this subgame is r, then if we make the combinations, then we can find out the other strategy, which is r, a and a. So this is the another strategy for the player 2. Now in the next step, we will try to find out to solve the subgame of length 2. Solve the subgame of length 2. Now what is the subgame of length 2? What we can call it? We can call s02. means the zero index sub game of length 2. So what can be the output? So to find out the output, we need to make the combinations. We need to make the combination with the output of the next lower level sub games. So we know the player 1 is having 0, 25, 50, 75 and 100. These are the actions for the player 2. Now what is the output here? To find out the output of S02, we need to first consider the strategies of player 1. Okay, we need to consider the strategies of player 2. Okay, so in the previous slide we have calculated the two strategies. This one is the first strategy of the player 2 and this one is the second strategy of player 2. So we need to consider these two strategies to find out the best action for the player 1. So if you see the first strategy, that is accepting the every offer. So accepting the every offer means this one is accept, this one is accept, this one is accept, accept, accept. He is accepting every offer. Now which offer is best? 0, 25, 50, 75, 100. Which offer is best? Because the player P2 is accepting every offer. Now which offer is best for the player 1 in response to this strategy? So here if P1 takes 0, then he will get the payoff of 100, because here the P2 is accepting the offer, so he will get 100. Now the P1 gives 25, the offer of 25. Now P2 is accepting the offer, then he will get 75. Now in this case he will get 50, in this case he will get 25, in this case he will get 0. So in which offer he is getting the maximum payoff? So this one is the offer at which he is getting the maximum payoff, that is 100, right? So if player 2 strategy is accept, 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 means he is accepting every offer. So which offer is best for the player 1? The offer of 0 is the best. So this is what? This is the strategy of player 1 and this is the strategy of player 2. So we can say here this is the best response strategy in considering with the strategy of player 2. Okay. Now what can be the other possibility here? In the previous slide we already have calculated two strategies are possible for the player 2, and I have considered the first strategy and we have got the best offer for the player 1 is 0. Now if I consider the second strategy, that is RAAAA. RAAAA means he is rejecting the offer of 0 and he is accepting all other offers other than 0. So you can see here he is rejecting that offer and he is accepting offer in every sub games, in all sub games. Means what? The player P2 is not accepting the offer of 0 and he is accepting any offer which is greater than 0. Okay. So if I consider this strategy for the player 2, now what will be the best response strategy for the player 1. So this is the strategy of player 2. R A A A A. So this is the strategy of player 2. Now what will be the best strategy for the player 1? We need to look at the game tree first. So you can see here in this case he is rejecting the offer. He is rejecting the offer. Here accepting the offer, accepting the offer, accepting the offer, and accepting the offer. So here he is rejecting, right? So if he rejecting the, if P1 offers 0, he will get 0. If in this case he is accepting the offer, at the offer of 25 he is accepting, so he will get 75. In this case the offer of 50, he is the player P2 is accepting the offer and the player 1 will get 50. At the offer of 75, the player 2 accepting the offer and the player 1 will get 25. And at the offer of 100, the P2 is accepting the offer and the player 1 will get 0. Now at which offer the player 1 is getting the maximum? So this is the maximum payoff for the player 1 at the offer of 25. So when the strategy of player 2 is RAAAA, means he is rejecting the offer of 0 and accepting all other positive offers. In this case, the minimum offer, the minimum offer except the 0 will be the best. That is 25. So 25 is the strategy of player 1. Of player 1. So these two are the equilibrium of this game. This and this are the two equilibrium of this game. So this is the end of the lecture. Thank you.